Let's now discuss how you find the argument of a complex number in quadrant 2. So remember, the argument theta is the smallest angle from the positive real axis to the vector of the modulus. So if this angle here is 25 degrees, if you were to go clockwise in the opposite direction, it would be 360, the total for one revolution, minus theta, the 25 degrees, which means this angle would be 335 degrees. So we know theta, or the argument, is always going to be counterclockwise, moving from the real axis in quadrant 1. Same thing in quadrant 2. The angle from the positive real axis to the vector of the modulus will always be shortest moving counterclockwise, because moving clockwise will always require going more than 180 degrees. Moving counterclockwise will always require going less than 180 degrees. So for example, if theta was 125 degrees this way, from here going clockwise, it would be 360, the total, minus 125, this angle, which means the remaining, this angle would be 235 degrees. So this angle is larger than this one, letting us know that theta here is our argument. Now, something interesting about quadrant 2, if the complex number is in the second quadrant, then subtract the alpha angle from 180 degrees to find the argument theta. So what does that mean? If we have a complex number that is in quadrant 2, so remember it's 1, 2, 3, 4. In quadrant 2, if we draw a dotted line from the complex number down to our real axis, our right triangle has an angle closest to the origin that is not our argument. Remember, the argument, or theta, is the angle from the positive real axis to the vector of our modulus. So we represent this angle for the right triangle as alpha. So in order to calculate our argument theta, it is the total 180 degrees here minus the alpha angle. So the remaining will be our argument. So 180 degrees minus the alpha angle is equal to theta. Calculating alpha, we'll still use the inverse tangent, or the opposite side over the adjacent side, to figure out what the alpha is, just like we did in quadrant 1 for theta. Except here we'll calculate alpha and then subtract it from 180 degrees. Now, one more thing to note. To find the inverse tangent of the alpha angle, use the absolute value of the opposite side divided by the adjacent side. In the second quadrant, the real number will be negative, but when you're using the inverse tangent, we're referring to the lengths of the side. So although in the complex number, the real number is negative, when we are calculating alpha, the adjacent side is going to remain positive, and the imaginary side will already be positive. All right, so ignore the negative for the real number when you're calculating the actual angle. Let's take a look at negative 4 plus 3i. So if you're asked to find the argument, step 1, go to negative 4 on the real axis, and step 2, draw a dotted line up to 3 on the imaginary axis, and then plot the point. Step 4, draw a line from the point to the origin. So we have our right triangle, and this angle here is our alpha angle, which means our right triangle has an adjacent side to the alpha angle that has a length of 4, the real number, and an opposite side equal to 3, the imaginary number. So now that we have this right triangle, we know that this angle here is our alpha, and the remaining angle along the real axis would then be our theta, or our argument. So we'll first need to calculate the alpha angle using the inverse tangent of the opposite side over the adjacent side, which would be 3 over 4. So we find the inverse tangent of 3 over 4 with a calculator in degrees mode, giving us that alpha is equal to the inverse tangent of 3 over 4 which shows us that alpha is equal to 37 degrees. When we subtract the alpha angle from 180 degrees, we get theta is equal to 143 degrees. If you wanted to get this answer into radian form, you multiply it by pi over 180 degrees. 143 degrees divided by 180 degrees gives you 0.79 radian. So the answer would be 143 degrees, or 0.79 radian. So that is how you go about finding the argument in the second quadrant. Let's have you complete a few practice questions. Question number 1. Find the argument of -5 plus 3i. Question number 2. Find the argument of -2 plus 4i. And question number 3, find the argument of -6 plus 8i. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, we're asked to find the argument of -5 plus 3i. So step 1, go to -5 on the real axis. Step 2, draw a dotted line up to 3 on the imaginary axis, and then plot the point. You then draw a line from the point to the origin, creating a right triangle, and the angle closest to the origin is our alpha angle. So the alpha angle has a side adjacent to it with a length of 5, the real number. And the alpha angle has a side opposite of it that is equal to 3, the imaginary number. And with this being our alpha angle, that lets us know from here to the positive real axis is our argument, or theta. So the fifth step, we'll find the inverse tangent of 3 over 5 to find our alpha. And then we'll subtract that from 180 degrees to find our theta. So the inverse tangent of alpha is 3 over 5. So the alpha angle is equal to 31 degrees. Subtract that from 180 degrees, and you get theta is equal to 149 degrees. To get this in radian form, multiply it by pi over 180 degrees. 149 degrees divided by 180 degrees is 0.83 radian. So the answer to question number 1 is 149 degrees, or 0.83 radian. Question number 2, we're asked to find the argument of -2 plus 4i. Step 1, go to -2 on the real axis. Step 2, draw a dotted line up to 4 on the imaginary axis. Step 3, plot the point. And then the fourth step, draw a line from the point to the origin, creating a right triangle. Our alpha angle is here, which means we have a right triangle with an adjacent side to the alpha angle that has a length of 2 and an opposite side equal to 4. So here is our alpha, which means our theta, or argument, is here. So we must first find the inverse tangent of the opposite side 4 over the adjacent side 2 with the calculator in degrees mode to find the alpha angle. So the alpha angle is equal to the inverse tangent of 4 over 2, which means the alpha angle is equal to 63 degrees. Subtracting that from 180 degrees gives us the argument is equal to 117 degrees. And in radian form, multiply 117 degrees by pi over 180 degrees. 117 degrees divided by 180 degrees is 0.65 radian. So the answer to question number 2 is 117 degrees, or 0.65 radian. Question number 3, You were asked to find the argument of -6 plus 8i. Step 1, go to -6 on the real axis. Step 2, draw a dotted line up to 8 on the imaginary axis. Step 3, plot the point. Step 4, draw a line from the point to the origin, letting us know that this angle closest to the origin is alpha. And our right triangle has an adjacent side equal to 6 and an opposite side equal to 8. So if this is our alpha angle, we'll calculate that using these sides. And then we'll subtract our alpha angle from 180 degrees to get the theta angle, our argument. So to find the inverse tangent of the opposite side over the adjacent, you do inverse tangent of 8 over 6. So the alpha angle is equal to 53 degrees. And now subtract that from 180 degrees. 180 degrees minus 53 degrees gives us a theta, or argument, of 127 degrees. And in radian form, multiply this by pi over 180 degrees. 127 degrees divided by 180 degrees is 0.71 radian. So question number 3, the argument is 127 degrees or 0.71 radian.